This is lesson 7, Friday, December 16. As we've seen the last few classes, we can add some intelligence to our programs with the use of branching of conditionals, if, else, and statements. Several of you have actually been asking whether we can start building some slightly more complicated expressions that evaluate true or false when we are doing our conditional statements. The answer to that is yes. Let me show you some of the ways in which you can combine Booleans to build more complicated expressions. So let's go into our interactive Ruby, and let's start with the keyword not. And the keyword not is essentially a way of flipping a true into a false and a false into a true. How do you use it? Well, very simply, you can do this. Not true is false, not false is true, and not true, as you would expect, would be true because it would be the not of not true, and not true is false, so not false would be true. There's a shortcut in Ruby for you to use not, and it is the use of the exclamation point. So if I say exclamation point true, that's false. Exclamation point false is true. And two exclamation point is two nots, and therefore becomes a true. This is actually similar to what we have seen in the context of other operators. If you remember when we did x equals 1, we can check whether x is equal to 1, and we get a Boolean true. But we want to know when x was not equal to 1, with emphasis on not. We essentially use an exclamation point next to the equal sign to check for that value. It's essentially the same exclamation point, the same symbol we use to indicate this negation. There are two other logic operators or Boolean operators that we want to talk about, and or. The idea about and is that and actually lets you link together two Booleans and will only return true if both Booleans are true themselves. So true and true is true. True and false is false. False and true is false. And false is false. So the expression is true only when both parts of it are true individually. Let's write a little program that lets us experiment with this. So in this program, what we're going to say is we're going to say print, are you happy? And the answer is you are happy equals gets.jump. Print, do you know it? And the answer is you know it is gets.jump. And you know how the song goes. If you are happy is equal to yes, and you know it is equal to yes, then you can clap your hands. And if you're not happy and you don't know it, then too bad for you. So let's run that. So let's get out of IRB and let's try to run not screen.rb. Are you happy? Yes. Do you know it? Yes. Everything is good. But if one of those is not true, then the result is false. One student asked in class a very good question, which is, could I actually combine this and say, if you are happy and you know it equals to yes? The answer is you cannot do that. And the reason you cannot do that is because Ruby wants to individually evaluate these statements and then combine them when they are each of them becomes a Boolean, yes, or true or false. The and then combine the two. When you say you are happy and you know it, it would try to actually treat you're happy and you know it as a Boolean and only give you true if both of them were true, and then compare that to the string yes, which is not a valid statement. So the short answer is no, you cannot do that. All right, so one more. How about the or? Well, let's see. True or true would be true. True or false would be true because one of the two of them is true. False or true is also true, and the only time we get a false is when both of them are false. We can use that to write another small program. In which we are going to ask the student to enter his or her grade in the course. And then we are going to print a useful message about the grade based on what we know of our grading system. So we're going to say if the grade is less than 0 or the grade is greater than 6, we know this is impossible, so we're going to say liar. Else if. So now we know that it's a number between 0 and 6. What numbers are we interested in? Grade equal 5 or grade equal 6. That's an honors grade. Else if grade is, I'll just say this, less or equal to 1. Why does this work? Because we already know that the grade is between 0 and 6. So if it's less or equal to 1, means it's a 0 or a 1. Then we can just put fail. And the else, it can be nothing else but 2, 3, or 4, and we just say pass. So you can see how by actually building our conditional this way, we're able to create a much more succinct, efficient program that checks all the different cases of grades. So Ruby grade, enter your grade, 4 is a pass, the 6 is honors, the 0 is a fail, and a -5 is impossible. The second exercise we want to work on today is to take another look at loops and start actually increasing the complexity of the logic we use in these loops. And the example we used in class today is trying to use a while loop to draw a Christmas tree on screen. And the idea is this, is we want to be building a Christmas tree, and we would like the Christmas tree to look like this. And I'm going to use just, kind of characters right now to depict what I want to do. So you can see that this is a tree that would have 3 rows, and you will notice that when you are at row number 1, you basically have a single point, single that we're drawing. Row number 2, you'll notice that we have 3, row number 3, you'll notice that we have 5. So what's going on here? And how can we actually figure out the number of points based on the row number? Well, someone in class figured out that the number of points is equal to 2 times the row number minus 1. So we're going to use this information to ask the user how big is the tree, meaning how many rows in the tree. And we're going to say that numRows is equal to gets.chomp.toI. And then we're going to start with row number 1. And we're going to say that as long as the row is less than or less or equal than the number of rows that we have to draw, we are going to use the special multiplication, I put that in quotes, of strings to draw the appropriate number of points. So we're going to use the character little hat like this, exponential, the exponential sign if you want. And we're going to multiply it by an expression which is 2 times the row number minus 1, as we saw above. That would actually give us the proper number of leaves, if you want. And then we would end. We talked about the fact that if I left this program like this, it wouldn't work. Why? Because I'm actually never increasing row, which means I would get an infinite loop. Row would start at 1, would always be 1, and therefore this while would never end. So it's important to actually increase row by 1. And what we saw in class today is that there's a shortcut for this, because we do this so many times, x equals x plus 1, that there's a shortcut that says row plus equal 1, which means row equals row plus 1. If I go to run this program, it's not going to look very good. If I say I want 5 rows, well, I get the correct number of leaves on my tree, but it is not centered. It turns out that there is a command for strings to center them over a given interval. So the first question is, how do we calculate this interval? Well, if you think about it, the width, the total width of the tree is represented by the number of leaves on its bottom row. That's how big the space in which we want to center things. So what I want to do here is, once I have numRows, I want to have a new variable called width, which is calculated at 2 times numRows minus 1. That's going to be the width of the base row of the tree. And then I'm going to take this string that we created. I put parentheses around it to make sure that the action I'm about to apply really applies to the string made of all those characters. And the command is center, so dot center. This is the object, which is the string. And we are going to tell it that we want to center each row over the width, total width of the tree. If I rerun my holiday tree, it looks a lot better. And you can make it as big as you'd like. That's it for today. This was lesson 7.